In our lesson today, we're going to learn about parallel lines that are cut by a transversal. Before we talk about what a transversal is, let's remind ourselves about parallel lines. Parallel lines are lines that never intersect. Okay, they're never going to touch. This means that the lines have the same orientation. If one line is going straight up and down, the parallel line will also be going straight up and down. Okay, so those two lines would never ever touch. You can think of parallel lines like railroad tracks, right? A transversal is a line that intersects one or more parallel lines. This means that the transversal will have a different orientation from the parallel lines. Okay, so you'll have at least two lines that are parallel to each other, and then a third line that's going to intersect those lines. So if we look at our picture underneath, all right, we have line N and we have line K. Lines N and K are parallel to each other. They've got the same orientation. They're both going straight up and down. Lines N and K are never going to intersect with each other. Line M is the transversal, okay? The transversal is intersecting both lines N and K. All right, so what we're going to do today is investigate different types of angles that are created when we have parallel lines that are cut by a transversal. In our picture, again, lines N and K are parallel to each other, and line M is the transversal that intersects both lines N and K. Notice that in this picture, there are 8 angles that are created, all right? And it could look something like this, okay? We can see the 8 numbered angles here in our picture. Which types of angles that you all already familiar with do you see in the picture? So if we think about our angle pairs, one type of angle pair that I recognize right away is vertical angles. If you remember vertical angles, those are created when lines intersect, and we definitely have lines intersecting in this picture. All right, vertical angles are located across from each other from the point of intersection. So if I start down here with angles 1, 2, 3, and 4, here's the point of intersection. All right, I'm looking for angles that are across from each other from that point of intersection. Angle 1 and angle 4 are vertical angles because they're across from each other from the point of intersection. And if we remember from before, vertical angles are always congruent. So I can say the measure of angle 1 is congruent to the measure of angle 4. Remember that this is the congruent symbol. All right. Also at this vertex point, I have angles 2 and 3 that are across from each other, making them vertical and congruent. The measure of angle 2 is congruent to the measure of angle 3. If I go up to this vertex point where I see angles 5, 6, 7, and 8, angles 5 and 8 are vertical and congruent. The measure of angle 5 is congruent to the measure of angle 8. And angles 6 and 7 are across from each other from the point of intersection, so they are vertical and congruent. The measure of angle 6 is congruent to the measure of angle 7. So I have 4 pair of vertical angles in this picture. Now, another set of angle pair that I'm familiar with were supplementary angles. All right, if you remember supplementary angles, these are 2 angles that form a straight angle, therefore meaning they have a sum of 180 degrees. So if I come down again to this vertex point where I see angles 1, 2, 3, and 4, all right, angle 1 and angle 2 are supplementary. They form line N if you put those together. So this means that the measure of angle 1 plus the measure of angle 2 has to add up to 180 degrees. All right, but angle 1 and angle 3 are also supplementary. They form line M, which is the transversal if you put those angles together. So the measure of angle 1 plus the measure of angle 3 must add up to 180 degrees. All right. Angle 2 and angle 4 are supplementary because they form line M if you put them together. So the measure of angle 2 plus the measure of angle 4 equals 180 degrees. And then angle 3 and 4, if you put them together, they form line N, that straight angle. So the measure of angle 3 plus the measure of angle 4 equals 180 degrees. So just at this one vertex point, I have four pair of supplementary angles that have a sum of 180 degrees. It's going to be very similar if I go up to this vertex point where I see angles 5, 6, 7, and 8. Okay, angles 5 and 6, if I put them together, they form line K, which again is a straight angle. So the measure of angle 5 plus the measure of angle 6 must be 180 degrees because they're supplementary. Angle 5 and angle 7, if you put them together, they form line M, the transversal. So the measure of angle 5 plus the measure of angle 7 has to equal 180 degrees. All right, angles 6 and 8, if you put them together, they form line M. So the measure of angle 6 plus the measure of angle 8 equals 180 degrees. And then finally, angles 7 and 8 form line K when you put them together, making them supplementary. The measures of angle 7 plus the measure of angle 8 equals 180 degrees. So when you have two parallel lines that are cut by a transversal, you get four pair of vertical angles, and then you also get 8 pair of supplementary angles. So in the last picture, we reviewed vertical angles and supplementary angles, and we're going to start to investigate some new angles that are formed when I have parallel lines cut by a transversal. The first of those are called corresponding angles. Okay, corresponding angles are angles that are going to be in the same position, just on the different parallel lines. Imagine taking the angles formed by line N and line M. So line N is this angle and line M is the transversal. So angles 1, 2, 3, and 4. Imagine taking these angles and sliding them up so that they overlap with the angles formed by line K and line M, angles 5, 6, 7, and 8. So if I take these angles, 1, 2, 3, and 4, and slide them up so that they land on top of angles 5, 6, 7, and 8, which ones will line up? Okay, these angles are called corresponding angles. So if I think about this, if I take angle 1 and I slide it up to this vertex point, that's going to land on top of angle 5. And if you notice, those angles are actually going to be congruent to each other. They have the same measurement. Okay, so corresponding angles are always congruent to each other. All right, since lines N and K have the same orientation, if I slide line N on top of line K up here, line 1 or angle 1 would land on top of angle 5, and those two angles would have the exact same measurement. So the measure of angle 1 is congruent to the measure of angle 5. They're in the same location, all right, just on different parallel lines, so they are called corresponding angles. Another set of angles that would be called corresponding to each other are called angle 2 and angle 6. Okay, if I slide angle 2 up onto line K right here, that's going to land on top of angle 6. They're in the same position. All right, they have the same measurement. The measure of angle 2 is congruent to the measure of angle 6. Also, if I take angle 3 and slide it up here, angle 3 is going to land on top of angle 7. They're in the same position, just on different parallel lines. They are corresponding and congruent then. The measure of angle 3 is congruent to the measure of angle 7. And finally, if I take angle 4 is in the same position as angle 8. So if I slide angle 4 up, it's going to land on top of angle 8, meaning that these two angles are corresponding and congruent. The measure of angle 4 is congruent to the measure of angle 8. So there are four pair of corresponding angles formed by the transversal and the parallel lines. The next set of angles that we're going to learn about that are created when a transversal intersects two parallel lines are called alternate interior angles. Okay, so using the same picture that we had before, again, lines N and K are parallel, line M is the transversal, and when line M intersects the lines, we get the 8 angles shown here. Okay, we want to find alternate interior angles. Okay, these types of angles alternate which side of the transversal they are on, and they are inside of the parallel lines. Okay, so that's what we're going to do, is see if we can find pairs of alternate interior angles. So if this is line N, all right, and this is line K, they're parallel to each other. I'm only going to look at the angles that are inside of these parallel lines, which are angles 3, 4, 5, and 6. Okay, what we need to have are angles that are on different sides of the transversal, okay, but they're also going to be inside of the parallel lines. All right, and what we see here is that if I look at angle number 3, okay, well, another angle that's on the inside, but on a different side of the transversal, is angle number 6. Okay, angle 3, if you look at that angle, that's an acute angle. And angle 6, if you look at that angle here, that also is an acute angle. Okay, these are called alternate interior angles, and they are congruent to each other. Alternate interior angles are always congruent. Okay, so I can say that the measure of angle 3 is congruent to the measure of angle 6. All right, now I'm going to look for another pair of angles that are inside of the parallel lines, but on different sides of the transversal, and they're congruent to each other. And when I look at angle number 4 and compare it to angle number 5, well, that fits the description perfectly. These two angles are called alternate interior angles. They're inside of the parallel lines on different sides of the transversal, and they're congruent. Angle 4 is an obtuse angle. Angle 5 is an obtuse angle. The measure of angle 4 is congruent to the measure of angle 5. There are two pair of alternate interior angles that are formed when a transversal intersects two parallel lines. The next type of angle formed by a transversal intersecting two parallel lines are called alternate exterior angles. In a similar fashion to alternate interior angles, if the angles lie on alternate sides of the transversal and are outside of the parallel lines, then the angles are called alternate exterior angles. Alternate exterior angles are always congruent. Okay, so it's very similar to alternate interior angles. This time we're just looking for angles on the outside of the parallel lines. So again, N and K are the two parallel lines. Line M is the transversal. And we're only looking at the angles that are on the outside of the parallel lines. That would be angles 1, 2, 7, and 8. Okay, and if I take a look at angle 1, all right, the angle that is on the outside that is congruent to it on the other side of the transversal is angle number 8. So the measure of angle 1 is congruent to the measure of angle 8 because they are alternate exterior angles. And then the measure of angle 2 is going to be congruent to the measure of angle 7. They are also alternate exterior angles. They're on the outside of the parallel lines on different sides of the transversal. The measure of angle 2 is congruent to the measure of angle 7. Okay, so there are also two pairs of alternate exterior angles formed when a transversal intersects two parallel lines. Next, we're going to talk about interior angles that are on the same side of the transversal, and then exterior angles that are on the same side of the transversal. Okay, so let's focus first on the interior angles that are on the same side of the transversal. So here's line N and line K, the two parallel lines. M is the transversal. And if I look at interior angles that are on the same side of the transversal, I would have angle 3 and angle 5. I would also have angle 4 and angle 6. Okay, let's look at angles 3 and 5. Angle 3 right here, that's an acute angle. And angle 5 found right here, that is an obtuse angle. Okay, so if I remember corresponding angles as well, angle 3 corresponds to where angle 7 is located. So angle 3 and angle 7 are the same. Well, angle 5 and angle 7 are supplementary because they form the line M right here, they form a straight angle, which means that angles 3 and angle 5 will also be supplementary since angles 3 and 7 are congruent to each other. If the angles lie on the same side of the transversal and are inside of the parallel lines, then these angles are congruent. Okay, this means that they will always have a sum of 180 degrees. All right, so if we list these, okay, let's do the same side interior angles. Well, from our picture, we were just saying that angle 3 and angle 5 are same side interior angles. So this means that the measure of angle 3 plus the measure of angle 5 is going to equal 180 degrees. Very similar to that, angle 4 and angle 6 are same side interior angles. Angle 4 is obtuse, angle 6 is acute. The measure of angle 4 plus the measure of angle 6 is going to equal 180 degrees. Now, in a similar fashion, we're going to have same side exterior angles. And I think you will notice that a similar pattern exists. This time, we're looking for angles on the outside of the parallel lines, but on the same side of the transversal. So if I look at my picture again, angles 1 and angle 7, they're on the same side of the transversal, but they're outside of the parallel lines. All right, now, angle 1 is corresponding to angle 5. So whatever angle 5's measurement is, that's the same as angle 1. Well, angle 5 and angle 7 are supplementary. They form this straight angle, again, line M. So that means whatever angle 5 is plus angle 7 adds up to 180. But since angle 5 and angle 1 are congruent, this also means that angle 1 and angle 7 would be supplementary to each other. So the measure of angle 1 plus the measure of angle 7 equals 180 degrees. And then angle 2 and angle 8. They're on the same side of the transversal, outside of the parallel lines. If I added those together, we would also get a 180 degree straight angle. So they are supplementary. The measure of angle 2 plus the measure of angle 8 equals 180 degrees. In our practice examples, we're going to use our first diagram to answer the questions in 1 through 12. Lines A and B are parallel to each other, and line C is the transversal intersecting the two parallel lines. The first set of questions, we have to tell what type of angle pair the given angles are. In number 1, they want to know angle 1 and angle 5. Angle 1 and angle 5. Okay, well, those two angles are in the same position, just on different parallel lines, which means that they are corresponding angles. Corresponding angles are always congruent. Question number 2, they want to know about angles 2 and 7. Angle 2 and angle 7. Here's angle 2, here's angle 7. They're both outside of the parallel lines, and they're on different sides of the transversal, which means that these are called alternate exterior angles. Alternate exterior angles are always congruent. Number 3, they want to know about angles 5 and 6. Here's angle 5, here's angle 6. If we put them together, they form the straight angle, which is line B, meaning that these are called supplementary angles. Supplementary angles always have a sum of 180 degrees. Angles 5 and 8. Here's angle 5, here's angle 8. They're on opposite ends of this point of intersection, which means that they are vertical angles. Vertical angles are always congruent. Next, angles 3 and 6. Here's angle 3, here's angle 6. These angles are both inside of the parallel lines on different sides of the transversal, which means these are called alternate interior angles. Alternate interior angles are always congruent. And then finally, angle 1 and angle 4. Here's angle 1, here's angle 4. They're on opposite ends of this point of intersection, which means that they are vertical angles. Vertical angles are always congruent. All right. In question number 7, they want to know if this is a true statement or a false statement. Angles 4 and 5 are congruent to each other. Okay, well, here's angle 4 and here's angle 5. They're both inside of the parallel lines on different sides of the transversal, which means they're alternate interior angles. Since they're alternate interior angles, I know that they are congruent. So this is a true statement. Question number 8, again, true or false, angles 3 and 6 are congruent. Okay, so we see angle 3 right here, angle 6 right here. Well, we already identified those earlier as alternate interior angles. And again, I know alternate interior angles are congruent. So this, once again, is a true statement. Okay, next, they want us to name the parallel lines. Well, looking at the picture, the parallel lines are lines A and B. So that would be line A and line B. In question 10, they want us to name the transversal. The transversal is the line that intersects the two parallel lines, which we see right here is line C. All right, so the transversal is line C. And in 11 and 12, they want some definitions. In number 11, they want to define complementary angles. Okay, well, recall, these are angles whose sum is 90 degrees. These are two angles that if you were to combine them, they would form a right angle. Number 12, define supplementary angles. Well, these are angles whose sum is 180 degrees. All right, again, if you put those two angles together, they would form a straight angle. In our next picture, again, we have two parallel lines that have been cut by a transversal, making the 8 shown angles. And we're going to use this picture to answer the following questions. Number 5 says, if the measure of angle 1 is 110 degrees, then the measure of angle 7 equals blank degrees. Okay, well, here's angle 1 and here's angle 7. Okay, they're not corresponding to each other. They're not alternate interior angles, they're not alternate exterior angles, and they're also not same side of the transversal angles. So what I'm going to have to do is see what angle 1 would be congruent to. Angle 1 would be congruent to angle 3 because they are corresponding angles. Okay, so if angle 1 is 110, then angle 3 is also 110. And then angle 3 and 7 are supplementary angles, meaning that they add up to 180 degrees. So if angle 3 is 110 degrees, that means that angle 7 must be 70 degrees. Question 6, if the measure of angle 2 is 110 degrees, then the measure of angle 4 equals blank. All right, angle 2 and angle 4, they are in the same position on two different parallel lines, making them corresponding angles, so they are congruent. So if angle 2 is 110 degrees, then so is the measure of angle 4. If the measure of angle 2 is 110 degrees, then the measure of angle 7 equals blank. So here's angle 2, here's angle 7. They're inside of the parallel lines on different sides of the transversal, making them alternate interior angles, making them also congruent. So if the measure of angle 2 is 110 degrees, well, then so is the measure of angle 7. If the measure of angle 1 is 70 degrees, then the measure of angle 8 equals blank. Okay, well, here's angle 7. Oh, excuse me, angle 1, rather. The measure of angle 1 is 70 degrees, and then the measure of angle 8 equals blank. Here's angle 1. Here's angle 8. They're outside of the parallel lines on different sides of the transversal, making them alternate exterior angles, which means that they are congruent. So if the measure of angle 1 is 70 degrees, then so is the measure of angle 8. And then finally, if the measure of angle 2 is 140 degrees, then what are the measures of the other angles? Okay, so let's start with the measure of angle 1. Angle 1 and angle 2 are supplementary, so if angle 2 is 140, then angle 1 must be 40 degrees. Okay, the measure of angle 3 I can get Angle 2 and angle 3 are on the same side of the transversal, and they're in between the two parallel lines. So these same side interior angles add up to 180. So if the measure of angle 2 is 140 degrees, then the measure of angle 3 must be 40 degrees. Also, 1 and 3 are corresponding to each other, so they have to be congruent, and they are. The measure of angle 4. Well, angle 2 and angle 4 are corresponding to each other, meaning that they're congruent. So the measure of angle 4 has to be 140 degrees. To get the measure of angle 5, well, angle 2 and angle 5 are vertical to each other, so they're congruent, which means that angle 5 is 140 degrees. For the measure of angle 6, angle 2 and angle 6 are supplementary. They form this straight angle here. So if angle 2 is 140 degrees, then angle 6 must have a measure of 40 degrees. Now to get the measure of angle 7. Okay, well, I can do this in a couple of ways. I know that angle 5 is 140 degrees because it was vertical to angle 2. And angle 5 is also corresponding to angle 7, so angle 5 and 7 must be congruent. So angle 7 must be 140 degrees as well. And now to get the measure of angle 8. Okay, well, angle 2 is corresponding to angle 4, so they're congruent, 140 degrees. And then angle 4 and angle 8 are supplementary, forming this straight angle here, which means they must add up to 180 degrees. So if angle 4 is 140, then angle 8 must be 40 degrees. So there's lots of different ways that we can get the measures of these different angles when we have two parallel lines that are cut by a transversal.